Hi, this is a mini lecture on statistics and psychology. Most of you have learned basic statistics in your algebra class, and some of you have already gone well beyond that in AP statistics. In AP Psych, we will review some of the basic concepts of statistical analysis that psychology researchers use, the measures of central tendency, the difference between descriptive and inferential statistics, the concept and calculation of standard deviation, the concepts of variability and skew, and perhaps most importantly, measures of statistical significance. The first slide lists the three basic measures of central tendency. These are three ways of looking at a set of data and trying to determine the statistical middle. The first is the mean, which is the one we use most often in everyday life. Mean is another word for average. If you have a set of data, for example, your grades on quizzes in AP Psych, you would simply add them all together and divide by the total number of quizzes to determine the mean. Let's assume your quiz scores out of 10 on 7 different quizzes are 7, 7, 7, 8, 9, 9, 10. If you add these together, you get 57. Divide by 7 and your mean score is 8.14. You never earned 8.14 on a quiz, but 8.14 is still a typical score for you. The second measure is the median. If you line up all the scores from lowest to highest, the median score is the one in the middle. In this case, your median score is 8. The third measure is the mode. The mode is the most common score. On this list of quiz scores, you earned 3 7s, 1 8, 2 9s, and 1 10. So your mode is 7. We will do a few examples in class to help us visualize central tendencies. Next, let's consider the difference between descriptive and inferential statistics. Descriptive statistics explain data. For example, if I ask everyone in class whether or not they like pepperoni pizza, and 27 out of 30 students say yes, I can report with confidence that 90% of the class likes pepperoni pizza. But this does not allow me to predict that 90% of all teenagers, or even all Mounds View students, like pepperoni pizza. If I want to be able to make that claim, my statistics must have validity. In order for survey results of a small group to be a valid representation of a larger group, I must ask a random sample of people and take a large sample size. We will do 2 activities in class looking at the importance of randomization and sample size. Psychologists want their research to have validity because they want to know that their experiments shed light on human nature, not just a few people. It's important for researchers to not be influenced by the vivid case. For example, one child who grows up with drug-addicted parents may thrive and become a famous neurologist. One should not conclude from this that the best way to become a neurologist is to have drug-addicted parents. We will talk more about validity in our unit on testing. The black swan fallacy is also a pitfall. People often assume that if they have never seen something, like a black swan, then it doesn't exist. If you ask 100 students if they like pepperoni pizza, and they all say yes, that does not prove that all students like pepperoni pizza. A researcher can describe with statistics how likely it is that all students like pepperoni pizza, but you cannot claim that no student dislikes pepperoni pizza. Psychology researchers are also interested in findings that show less variability and a larger difference. We looked at variability in correlation statistics. Now we will look at it with a distribution curve. Let's say we have everybody in a group run a mile and we record their times. On the slide, you'll see we've done this for groups A and B. The next step is to calculate the mean or average time. In both of these groups, the mean is 8 minutes. If you look at the 2 groups of data, you can see immediately that group A has more variability, a larger distribution of times. We can quantify this variability by calculating the standard deviation. How? First, we calculate how much time each time differs from the mean. Notice that in group A, the first runner's time, 5 minutes, is -3 from the mean. Then we square each runner's time and add the squares together. Let's look on the next slide, where this has been done. Notice that the total is 26. Finally, divide 26 by the number of runners, 10, to get 2.6. If you look at the equation on the lower right-hand side of the screen, you will see what we have done is we have taken the mean and subtracted it from each runner's score, squared the runner's scores, summed them, divided by the number of runners, and then we will take the square root of that to reach the standard deviation. The square root of 2.6 is about 1.61. What does that mean? It means that in group A, the average time is 8 minutes, and 68.3% of runners fell within 1.6 minutes, or a minute 36, of that time. Now you should do the calculations for Group B. You should find a lower variability, meaning 68.3% of runners will fall within a span even closer than plus or minus a minute 36. The next slide shows a normal curve, a concept we'll look at more closely in our unit on testing. A curve with low variability would be taller and skinnier in the middle, while a curve with high variability would be flatter. Results are more significant when there's low variability. On the next slide, you see two types of skewed distributions. Students often confuse the negative and positive skews. The negative skew, shown on the left, means that the tail on the left is longer than on the right, so most values are clumped together here on the right. On an easy test, almost everyone would perform well. Very few would do poorly. This would result in a negative skew. The mean would be smaller than the median in this case, with a few negative outliers pulling down the mean. A very difficult test, on the other hand, would result in a positive skew, since most scores would be very low with only a few high outliers. The final slide is perhaps the most interesting point for researchers. If you are conducting a psychology experiment on two groups, say test scores for students who got 8 hours of sleep the night before and test scores for students who got less than 5 hours of sleep the night before, you would create a distribution curve for each group. Then you can measure the difference between the two groups' means using something called a t-test. This test will generate a p-value, a representation of the probability that the difference in your two means came about by chance. We won't go into the details of those calculations here. They're beyond the scope of an AP Psychology class. What's important is to understand that researchers want to ensure that their observed difference didn't just happen by chance. Psychology researchers use a maximum p-value of 0.05, which means they want to be sure that the different outcomes in their experiment would occur less than 5% of the time by chance.